In approximately 1 billion years from now, the Earth will become too hot to sustain oceans on its surface, and all life here will be gone. That's why we're already searching for a new home. The explorer within us made it possible to conquer the most inhospitable corners of our planet. We navigated through the dense undergrowth, creating paths where none existed before, discovering new biological species, and establishing a safe habitat in the middle of jungle wilderness. In the early 20th century, adventurers equipped only with rudimentary gear explored the realm of eternal ice and silence, Antarctica. Survival in this frozen wasteland took superhuman creativity and adaptation. Today, our ambitions extend far beyond the most secluded parts of Earth. As we look into the night sky, we wonder, is there another place like home for us? For a long time, we've considered Mars as the next stop in humanity's cosmic history. That turned out to be nothing but a fantasy, a long-shot projection impossible to achieve, and it looked as if there would be no place else for us until one day we discovered Titan, an enigmatic celestial object so similar to Earth it revived our hope in the search for a second home. What does it take to build a colony millions of miles away from Earth? Why is colonizing Mars a bad idea, and is our technological progress sufficient to send human colonists on a one-way trip to Titan? On Earth, there's terrain we can work on, oxygen we can breathe, drinking water, comfortable temperatures, and a shield against all kinds of radiation. All of these conditions are vital for life as we know it, but finding them elsewhere in space is like winning the lottery. Take Mars, for example. Geological records show that the planet was once like Earth. Mars had lakes on its surface, a warm climate, and potentially life, but all that has long been gone. Today, the planet is nothing like what it used to be. Colonizing Mars makes no sense. It's a lifeless desert where the average temperature is a bone-chilling -80 degrees Fahrenheit. It's a distant world where radiation is so strong that each step on the Martian soil brings you closer to your ultimate demise. But let's imagine we decided to establish a colony on Mars. What would it take? A crew of colonists boards a space rocket on Earth, and about 7 months later, they will be the first humans to step foot on the red planet. The first task is to build a safe habitat, a sealed environment capable of preserving the right air pressure, oxygen levels, and temperature. The area has to be big enough for people to live in, have all the necessary equipment to stay alive, and have room for inside projects like excavation or farming. Scientists are studying Mars for the safest location rich in minerals, where the first megastructures will soon be built. A chain of large domes is the foundation of the future settlement. One problem is they shelter from intense cosmic radiation and dust storms. From here on, excavators start digging up soil, and 3D printers turn it into physical structures. Humanity builds its first housing on an alien world. Buildings extend underground where they are connected to other domes through a system of tunnels. At this point, the colony no longer has a threat from external sources, but it still relies on a constant supply of water, oxygen, and energy. Life in a colony is not easy. Biologists spend most of their days figuring out ways to enhance vegetation growth. This requires uninterrupted focus as even slight fluctuations in temperature, pressure, gravity, or humidity threaten the entire harvest. At one point, the colony will fully depend on it. Geologists, along with scientists, are the ones living outside of the domes for the most part, searching for potential ice deposits. Nothing ever goes to waste. Water, minerals, sweat, and even urine are recycled. 3D printers are used to create spacecraft components and essential instruments. Shipments from Earth take too much time, and the colony might not have it. The system is fragile. There's no room for error. Sustaining the colony requires a lot of energy. Energy production becomes a critical cornerstone. Sandstorms on the red planet are irregular. Once sand grains rise into the atmosphere, they create a thick veil that blocks the amount of light the solar panels can receive. And when sand settles, it covers the panels. Robots ensure the proper functioning of solar energy generation, but they too require maintenance, and leaving the domes means being in constant danger. Mars has a very thin atmosphere, about 100 times thinner than Earth's. In other words, there's 99% less air on Mars than on our planet, and a lot more objects from space make their way to the ground without burning up. Because the planet's core is frozen, there's no magnetic shield. Cosmic and solar radiation are a constant threat. Each suit is equipped with sensors signifying critical levels of solar radiation in the atmosphere and potential danger coming from space. A significantly thicker atmosphere with a comfortable climate would eliminate several key problems. Elon Musk has put forward an intriguing suggestion to artificially generate an atmosphere on Mars by raising global temperatures through detonating nuclear bombs over its poles. The reality is, it won't work, and here's why. Water vapor and carbon dioxide are essential greenhouse gases on Earth, while Mars has a large amount of CO2 in its atmosphere. It's only 1% as dense as Earth's atmosphere, so there's less of this gas overall. A big portion of the carbon dioxide on Mars is trapped in non-atmospheric reservoirs, such as polar ice and minerals, making it difficult to access. But even if we could somehow access these reservoirs, the available CO2 wouldn't be sufficient to impact the planet's atmosphere. Atmospheric pressure feels like the weight of the air around us. At sea level on Earth, it's 1 bar, and it's like having 1 kilogram of air pushing down on every square centimeter. Currently, Mars has a very low atmospheric pressure, just about 6 bars, that's about 15 grams of carbon dioxide per square centimeter. To sustain liquid water on the surface of the red planet, you'd have to increase it to roughly 2,500 grams per square centimeter, over 150 times more CO2 than Mars currently has. It's like trying to fill up a balloon, but there's not enough air to do it. Melting polar ice caps to release water vapor is doomed for failure if there's not enough heat-trapping gas in the atmosphere. The resulting water vapor would just freeze back because of the low temperatures. And let's not forget about the radiation released from nuclear warheads, which would make Mars even more uninhabitable, at least in regions closer to its poles. It's all an intriguing thought experiment rather than a practical solution. The only thing that makes Mars an alluring planet is its relatively small distance from Earth. But is that really enough for us to throw in all the technological progress we've achieved and most of humanity's resources for a fraction of a chance like this? What if there's a world better suited for our cosmic ambitions? Titan is a cold, icy moon that orbits the planet Saturn and is even further away from Earth. So, what makes it a better candidate for a future human settlement? We've already built one space colony, the International Space Station. It's separated by a mere 250 miles from Earth, and its crew requires continuous resupply of resources, just like a hypothetical colony on Mars would. But Titan already has an abundance of resources on its surface and underneath it. It's just a matter of collecting, repurposing, and recycling them. It took the Cassini spacecraft nearly 7 years to reach Saturn. Looking ahead, with potential advancements, it's possible that in about 50 years, our technological progress could enable transporting a group of human colonists to the Saturnian system in just about 2 years. In the middle of the desolate expanse of Titan, where the average temperature sits at minus 300 degrees Fahrenheit, a brave group of settlers dreams of building their future. Titan is over 5 times further away from Earth than Mars. Embarking on a journey like this means leaving home and never coming back. One major advantage Titan has over Mars is its atmosphere, which is about 50% thicker than Earth's. Just this factor alone makes terraforming the moon much more feasible. A dense atmosphere means it's easier to trigger a greenhouse effect, bringing the temperature up. Even a slight temperature increase of about 75 degrees Fahrenheit could potentially be enough to turn liquid methane into a gas, which would lead to a chain reaction, setting in motion a range of transformative events. The liquid methane rain cycle stops, ice starts melting, and the moon becomes covered with an ocean. But that's a long-term projection. All this takes time, and a lot of it. So far, the colony operates under a deadline with finite resources of energy, food, oxygen, and water brought from Earth. Just like on Mars, settlers need specialized heated suits and respirators, but at least they won't have to be pressurized. The atmospheric pressure on Titan is 50% higher than on Earth, which feels like being 50 feet underwater. On Mars, it's too low, and if you tried walking there without a pressure suit, it would be almost like being exposed to open space. Skin and muscles swell and expand, joints become stiff, lungs rupture, and the fluids in the body, including blood, boil, not a fate most would choose for themselves. The surface of Titan is hostile, yet it's a treasure trove of resources. For one, Saturn's largest moon is a hydrocarbon factory. One of the hydrocarbons is propylene, which on Earth is used to form a basic ingredient of plastics and resins. The materials humanity has mastered for ages become key construction resources on Titan, used to create durable, lightweight structural elements for habitats, insulation materials, tools, and perhaps someday even components for communication devices. The colony lives in eternal dusk, and even when it's the brightest part of the day, Titan is still shrouded in a hazy atmosphere, making settlers' navigation on the moon challenging. But they may soon witness one of the most beautiful sights of Saturn in the sky, magnified 10 times compared to Earth's moon.